Welcome back, everybody. This lecture is about solving quadratic equations by the method of graphing. So believe it or not, you can use your graphing skills to solve quadratic equations. We have an equation here, x squared minus 4x equals 0. It's a quadratic equation. We want to solve it by graphing. So if the right side is 0, well, it's a quadratic equation. On the left side, we have some sort of quadratic expression. But if one side instead of being 0, if it is y, then it's called a quadratic relation. So if I write x squared minus 4x equals y, then this is called a quadratic relation. But if instead of y you have a 0 or even any other number like 1, 2, 5, then it's called a quadratic equation. So we have to know the differences. So what is given to us is a quadratic equation. But in order to solve this quadratic equation by graphing method, we are going to consider the related quadratic relation, not the equation, but the relation itself. And y equals x squared minus 4x is the equation of a quadratic relation whose graph is a parabola. And we can graph this parabola using table of values method. We can use any other method we feel like it. End of the day, we just draw the graph of this parabola. So right now, perhaps I can quickly factor x out, and I can say that this is x minus 0 times x minus 4, quickly writing it in factored form, and I can say that the r is 0 and the s is positive 4. So I know r and s are the x-intercepts of this parabola. And if I want to find the coordinates of the vertex, the x-coordinate of the vertex is r plus s divided by 2 because it's the halfway between the two x-intercepts. So that's going to be a 2, basically. And to find the y-coordinate of the vertex, we can always plug in 2 in the equation. So it's going to be 2 times negative 2, negative 4. So I can quickly draw a sketch of this parabola. I know the vertex is located at 2, negative 4. And I just plot that. That's 2 and negative 4 right there. And I know the x-intercepts are 0 and 4. So one is there at the origin. The other one is at 4. And I don't want to graph a very accurate, graph. If I just sketch it is good enough for this purpose, although you can, one by one sit down and plot the points very accurately. I can do it if necessary. So 1, 2, 3, 4, 5. So I can, find those. But the point I want to make is that as long as you draw the graph of the parabola showing the x-intercepts, that's good enough for this purpose. And now I'm going to draw a smooth curve passing through the points. So here there's some sort of semicircle at the bottom. It's a smooth curve passing through all these plotted points. So I'm trying to do my best. On a graph paper, you can do a better job. So this is the parabola that we draw end of the day. So a quadratic equation was given, but you graphed the related quadratic relation, okay? And needless to say, the axis of symmetry is the line x equals 2. It's a vertical line cutting the parabola in half. I just label the axis of symmetry, the vertex located at 2, negative 4 clearly. So in brief, you just draw the graph of the parabola. End of the day, this is a graphing method, right? And then, believe it or not, you're done. Because all you have to do is to read the x-intercepts of this sketched parabola. So one x-intercept I read here is like 0, and the other one is like 4. So x equals 4 and x equals 0. These are the x-intercepts of the parabola, okay? X equals 0 right there, x equals 4 right there. These are the x-intercepts. So the x-intercepts of the graph are actually the roots of the quadratic equation. So I write here x-intercepts of the parabola, okay, are actually the roots, or actually solutions, sometimes we call solutions, or the roots of the quadratic equation. And now that I'm talking about this, let me add that we call them actually the zeros of the quadratic relation. So all of these three things are the same thing. Zeros of the quadratic relation is the same as the roots of the quadratic equation, and it's the same as the x-intercepts of the graph of the quadratic relation. In other words, the x-intercept of the parabola. So if somebody says, okay, this is the quadratic equation, what is the solution? What's the answer? If you solve this quadratic equation, the answers are nothing but the x-intercepts of the graph. So x equals 0 and x equals 4 are the two roots of the given quadratic equation. And we solve this, we figured this out by drawing the parabola. If there's another question, let's say negative x squared plus 9 equals 0, okay? So this is a quadratic equation, but I can write the related quadratic relation, which is negative x squared plus 9 equals y, and this is like a parabola, right? You can construct table of values, you can use any method of graphing you have learned in the past, you know. So for example, I can go negative 2, negative 1, 0, 1, 2. I can plug in negative 2, that's going to be negative 4 plus 9 is going to be 5. Plug in 1, it's going to be 8, 0, 9, 8, and then 5. So if I plot these points on a grid, now here I may not have enough room, so 7, 8, yeah, it's going to be top. Well, maybe I can just do it, or I may just draw a new, set of x and y axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 here, and then 1, and this is 2, 1, and this is 2. That's negative 3, that's positive 3. So if I plot the points, 0 and 9 is there, 1 and 8 is right here, negative 1 and 8 there, 2 and 5, it's 1, 2, 3, 4, 5 is right here, and then here I have another one. So if I pick a negative 3 or 3, I end up with actually 0, believe it or not. So when I'm plotting these points, when I'm drawing this parabola, which is opening downwards this time, it's going to cross the x-axis at 3 and negative 3, believe it or not, okay? So there you go. This is the parabola opening downwards, and there is one x-intercept here. This x-intercept equals 3, and this other x-intercept right here, x equals negative 3, is the other root. So we're going to say that this quadratic equation has two roots. One is x equals negative 3 right here, and one is x equals positive 3. Whatever the x-intercepts of your parabola are, those are actually the roots of that quadratic equation. And you may ask, what if we have a graph of a parabola which is opening upwards and it does not even intersect the x-axis at all? Well, in that case, when there is no x-intercepts for the graph of your parabola, then there's no roots for the quadratic equation either. So we're not surprised about this. If it, for example, touches the x-axis at only one point, then you have only one x-intercept. That means that the quadratic equation has only one root. If it doesn't even intersect the x-axis at all, as I said, then in that case you don't have any x-intercept, you don't have any roots for the quadratic equation. And oftentimes, like in this example or in that example I did for you, we have 2 points of intersection between the parabola and the x-axis. So in this case, we have 2 distinct real roots for the quadratic relation. So it all depends on the parabola intersecting the x-axis or not. And if it does it intersect at 2 points, or does it intersect at 1 point? That would determine the number of roots that the quadratic equation has. So bottom line, in brief, draw the graph of the parabola related to the quadratic relation, and read the x-intercepts. As simple as that. Read the x-intercepts, and that will be the roots of your quadratic equation. This is just another method of solving quadratic equations known as graphing method. Okay, we have factoring method, square root method, quadratic formula method, and graphing method. There's 4 methods of solving quadratic equations, and each one of them has its own pros and cons, of course. Okay, stay safe, stay happy, and keep practicing as much as you can. Thank you very much.